Welcome to this video, Example, Parsing Wikipedia. In this video, we're going to walk through a complete example of parsing some information that has been inconsistently laid out on a Wikipedia page. We're going to see BeautifulSoup in action using a combination of what we've learned so far: CSS selectors, BeautifulSoup objects and methods, and bare bones Python to extract the data we want. Okay, let's get right to it. So this is the website that I'm interested in. And I've chosen it specifically because it's not very clear cut. If I scroll down, the data that I'm interested in is the data in the first cell here, the name and the date of the beginning and end of the monarch's reign. But unfortunately, the data here is slightly inconsistently arranged. You can see here, there's a pronunciation thing going on. And then down here, there's more details about the monarch. So we're going to have to combine our knowledge of HTML with some Python hackery. And this is very typical of scraping websites, unfortunately. To save time, I'm just going to tell you in advance right now that there are 57 monarchs listed on this page. So that's going to help us refine our query. So let's start by looking in the developer console to narrow down a CSS selector. If I go inspect an element, the first thing that's probably the most easy to see is that all of these tables have a class wiki table. So let's first start by filtering on that. So there's 24 tables, and let's look at that if that's right. So the first table is being highlighted, so that's probably right. And the last table is also being highlighted, so that's probably right as well. It's a good way to easily refine your queries to make sure that they're working. I'm going to go a bit further now and narrow in by using the table cell tag, which is TD. So that's 381, so that's still far too big, but if I expand this out, you'll see that what's going on now is it's selecting every single table, not just the first, which is where the data that I'm interested in is. But what I can see is that it looks like only the first column has a bold entry. So let's look at that. If I inspect on this, there's a TD and then a B for bold and then an A for an anchor or a link. So let's see if we can refine using that. So that's a smaller query. And okay, now there's 58 elements. So like I said before, there are 57 monarchs listed on this page, so this query looks like it's being quite accurate. And you can see it's selecting the names of these monarchs. So we have one over the amount that we want, and it's probably safe to assume that's either the first or the last. So let's look at that. Nope, the first element is that, so it's probably the last here. Let's take a look here. And yeah, you can see that this is selecting this item here, which isn't exactly what we want, but that's close enough for now because we can use Python to ignore that last element. So let's not waste any time by refining our CSS selector more than we need for practical reasons. So I'm just going to copy and paste this selector and let's move over to the Python. So you've seen all this code before, but basically I've just downloaded the website locally so that I can repeatedly run the script as we develop it without any concern. So the first thing I'm going to do is I'm going to go for the anchor and the soup that we select. And I'm interested in this query here. So let's print out what we're getting so far. So far all of that looks good except for that last index at the end. That says list of British monarchs, which isn't one of these. It's not a list of a monarch. So let's filter this out. So using Python, it's fairly easy to ignore that last element of the list. I'm just going to go :-1. And now if we rerun this script, yeah, you can see we're ignoring that last element. So the first thing I want is the name of the monarch, and I'm fairly confident that it's just going to be the text within this link. So let's do that. Let's go name equals a.text, and I'm going to start by printing that out. Okay, and you can see that that's successfully working. So now we're also interested in getting the date from the cell. So instead of using another query to find the first cell, we can use this anchor tag that we already have and find its parent ID tag. So let's do that. So the cell is going to be the A, and then we can say find parent. And we want the TD tag that the anchor is nested inside. So now I'm just going to print that out to make sure that we're getting that correctly. And it seems that we are. So now let's go back to the website, and we can see that unfortunately, it doesn't look like the dates are particularly consistently laid out. They're not nested in some sort of HTML tag that has a class or an ID. But one thing that I can see just by looking at it is that they always seem to be on a new line. And the new line always seems to be separated by this dash character. So this by itself might be enough to get us started. So let's go back to our Python code. And let's set the contents of the cell to be the cell text, and then let's split it on new lines. And let's print that and see what we get. Okay, so look at this. It is true in the Python that in this list, the dates are usually separated by this dash character. So let's start working from this. So the first thing I can do is locate the dates by looking on either side of the position of that dash character. So I'm going to say date1 is the contents, and then I'm going to go to the contents and I'm going to say the index of this dash character, and I'm going to look one before that, and that's going to be the first date. And the second date is going to be the element after that index. And so now let's print the data we have. We have a name, a date, and another date. Okay, so this seems like it's working. There's a lot of dates and then names, but unfortunately we got an exception. It says that that dash wasn't in the list. And so unfortunately with web scraping, there will always be certain outliers. So for now, let's put in a try and catch. So I'm going to say try, and then I'm going to put in an except. And if not, let's print the contents. And I'm going to have to comment out this. Okay, so we have two exceptions. Now this might end up being a little bit more hacky than I would ideally love, but with web scraping human-made websites, this is always a reality. So let's look at these dates here. So it doesn't look like we can use the list index because the first date here is the third index, and here it's the second. But note that in both of these exceptions, that the second to last date is the second date. So we can grab that date no problem. Date 2 is going to be the contents, and we can say the second to last by doing -2. Now with the first date, well, that's going to be the index before that, so that's going to be the third to last. So we can also get that. Let's go date1 equals contents -3. And let's print out the date that we get here. So this and this seem to be correctly working, except that it's putting the dash in there. So let's put a replace this dash with an empty space and rerun it. Okay, now it seems to be mostly working. There's still a trailing space here, so let's strip those spaces out for everything, and then we'll print out the elements. Okay, so that seems to be mostly working, except for one problem that we're getting these references in square brackets. So let's filter out all those references in the beginning of the script. We can go for r in soup.select, and I already know that those have a class reference, and we can go r.replace with, and this is a BeautifulSoup method, and I'm just going to say nothing. And now if I rerun the script, all of those references have been removed from the script. And now we're all done with the scraping, but just for the end here, I'm going to put in some code to write all these rows to a CSV file. So I'm going to say table equals an empty array, and I'm going to say table dot append. Then down at the end, I'm just going to write all that to a CSV file. And at the beginning, I'm going to import the CSV module that I'm using to do that. And now let's write this. And now if I look up monarchs.csv. Let's open this, and there it is. We've successfully scraped all of the English monarchs and their starting and ending dates of their reigns. So thank you for working with me through this script. And it's fairly short, but as you can see, it takes a while to really figure out exactly what you want, and unfortunately, you're always going to have to find little workarounds if there aren't consistently laid out data. But I think this has been a good example. In this section, we have looked at requesting HTML using both Python and the wget program. We have also learned the difference between client-side and server-side websites, and how to figure out if a website can be parsed with BeautifulSoup. We've also gotten our hands dirty with BeautifulSoup, and we've brought all of our knowledge together to work through a slightly more complicated example of web scraping than we've seen before. In the next section, we're going to steer away from traditional scraping, and instead we're going to look at the methods of gathering data online that doesn't require us to manually navigate the HTML of a website. Instead, we'll learn to directly request the information we want.